My name is Sandro Pereira, and I'm here once again on the Logic App Community Day talking about this time error handling. So everything that you need to know about error handling, both in Logic App Standard and Consumption. I'm the head of integration at DevScope. I'm a long time an Azure MVP. I think this year is the 14th time that I'm on the program, and it's a pleasure to be here. You have my contact information there, my email, my LinkedIn, my blog. So feel free to reach me out if you have any questions regarding to these topics or any kind of topics related with enterprise integration. I'm also an instructor of trainings about Azure integration and BizTalk. So if you have a need for that, also feel free to talk me and contact me for that. Now, one thing is clear on enterprise integration is that at some point we will have a fail in our process. So they will fail, okay? That's 100% sure, but at some point in time, they will fail, okay? And I normally say that failure is good. We need to learn from failures to keep upgrading and improve our process. So it's a step to the success of our integrations to be more robust and effective, okay? One of the things that is important to know is how to handle these exceptions, okay? How to control these exceptions inside our workflows in order to guarantee that they are robust and we can recover from that, okay? There are many ways to do that. So if we do an analysis with the C# code, and I know that most of our developers, we came from this programming language background, we know very well, we will have a try, a catch, and sometimes a try catch finally, and that's quite easy to accomplish in C# language or in other type of language, okay? We want to have the same capabilities inside our workflows, inside our logic apps. And this is what this session is all about, okay? So again, there are many ways to accomplish that, but basically, the way that we implement the try catch finally, or a try catch symbol, is with scopes, okay? We create a scope, let's call it our try scope. We put all the actions inside, can be straight actions, or it can be conditions inside, and so on and so forth. And then just after that scope, we create another scope, and let's call it a catch scope. And we need to define the run after settings. And for that, we have to say that if something fail or if there is a timeout on the try scope, that is just the action above, then this action needs to be executed, okay? So if some problem happens inside the try, the catch will be triggered and be executed all the actions that are inside, okay? So with these two conjugations of scope, we have a try catch. Now, if you want to implement a finally, just below the catch scope, we create a finally scope. And then once again, we have to configure the run after settings of that scope and basically select everything. If something happens on the catch, if it's success, the catch, we need to execute the final because the final always runs. If something fails on the catch, once again, the finally only runs. So you have to select all of these in order to say, no matter what happens with the catch, I'm going to be executed, even if it's skipped, okay? If it's skipped, normally that means that the try scope was executed successful. So all of these has to be selected. And with these three conjugation of scopes, we have a try catch or try catch finally implementation inside our logic apps. No matter if it's consumption or standard, it's the same. We are here still the old designer, but when we go to the examples and the demos, you will see that with the new designer is the same. Okay, it's just a matter of presentation. Okay, so with these three conjugations, we have a try catch or a try catch finally. Now, as I say, there are many options also inside logic app, not only this one. Okay, so each action that we add to our workflow, they have a run after settings that by default is if the previous actions is successful. Okay, if the previous action run successful, then the next one is going to be executed. Otherwise, there is an exception that is thrown and the workflow fail. Okay, if you do not implement the try catch approach. Now that also works inside the try catch. So each action inside the scope or the try catch scope also has this particular configuration. So each action has a run after setting that we can configure. That means that even if you do not implement the try catch scope, if you configure these actions according to what you want to accomplish, you can recover from failures. Let's say that we have a logging action. If it fails, we don't want to kind of abort the process. Just go to the action below. That means that, let's say that this initial variable is the logging shape. We on the next one we can set up if successful or if it's a fail or timeout. We can move on to the next action and execute to not terminate the workflow with an exception. Okay, and this you can do per action. But sometimes we want kind of having a control, and we create a try catch that we normally do. Now, another thing related with failures is that the connectors. So when we connect to a system, there may happen an error, like a connectivity error or an internal error. Okay, but sometimes there are connectivity errors. And with this type of connectors, we can also have the option to have retry policies. Okay, do not raise an exception on the first error that appears. Okay, and we can. There is a default retry policies that is kind of. I have 4 times with the interval period that the engine will kind of decide that for you, but you can also set up and customize your retry policies. Fixed interval, the number of times that we want to retry to see if we recover for that failure, and the interval between retries that is specified in ISO 8601 format. In this case, PT 20 seconds. That means each 20 seconds, we are going to retry to see recover that. Okay, and only finalizing the number of retries, you will get an exception, and you can control that exception. Otherwise, it's going to retry. So that will also save you time and create more kind of robust integrations, not to raise a failure only if there is a timeout that sometimes you can recover after 5-10 seconds. Okay, so there are many ways inside logic app, and logic app provides a robust mechanisms for you to control the retry policies and retry and catch all of the exceptions that happens inside your workflows. Okay. So another thing that when we get and control the errors is how do we get the error message? Because sometimes we want to know and log in a system the error message to analyze and so on and so forth, but also how to throw custom exceptions, okay? Because sometimes we have a workflow logic is so kind of complex that instead of having if conditions to control all of these, we can just have a condition that if something happens, or a validation fails, throw an exception, and go to the end of the workflow instead of having a big, complex nested if conditions. So these two questions appears often. And unfortunately, well, if you do the same comparison with C# code, throw exceptions is throw a new exception, and inside the catch we have the exception object, and we can go to exception option dot message or two strings and get the error message. Okay, so unfortunately inside logic apps that is not going to be that easy. It's going to be a little bit more complex, but it's going to be possible to accomplish that. Okay, so without saying more, let's go and see that how we can in a demo do the try catch, but also get the error message and throw the exceptions. Okay, so the first implementation that I'm going to present is using the out-of-the-box capabilities of the logic apps. Okay, so we have a logic app that is triggered by HTTP. We just have a kind of a demo logic, creating some variables, and then we create our try scope. Inside the try scope, there is a condition, a few more actions like setting a variables. And here, I just use a function that I have deployed in my Azure functions, and that's going to raise an exception. Okay, this is going to fail. This is just a simple function that converts an XML to JSON, but actually I'm sending a JSON, not an XML. So it's going to fail. It's I'm forcing to have an error. Okay, and of course we have a catch below the try scope, and if you see the settings, I have configured the as timeout is keep it or fail. Okay, and to get out of the box the error message, we can use the expression result and the name of the action that we are kind of getting the results. In this case, is the try scope. Okay, because the only is the only one that I know that I'm controlling. And then what we can do is, well, we do a filter by status equal to fail. So we are going to go get the result of that try catch action, filtered by the failures, and then we are going to get the first error back and present to the user. Okay, so I have it here, my Postman collection, and I'm just going to send a dummy empty message, and I'm going to get a result that is an action fail, no dependent action succeed. Okay, that is what we get. And now if you go to the run histories, let me just go to run histories, and this is what we get from our try scope. Okay, so the try scope, it says action fail, an action dependency is not created. Okay, some error happens inside that try scope, but what we really want is this one, the XML. This is where the error failed, and the correct error message is error converting an XML to JSON. Okay, so this is the error that we really want to have, not a generic error saying that something fails. Okay, because this is what we get from the response. Action fail, an action fail, no dependency action succeed. Okay, but unfortunately we could do that if we do the let me go to the edit mode now. if we only put the correct name of the action inside the result. So inside the result, if we, instead of putting try scope, if you put the XML action, then we get the specific result of that action. But the problem is that when we have a try scope, there may be a complex logic inside, like if conditions with loops and so on and so forth. We don't know exactly the action that is going to fail, so we cannot put the action name here. We have to put the try scope, and out of the box, we only get the generic error that is no dependencies, an action fail. Okay. So that means that we need to create different strategies. And one of the way is to create a generic logic app, for example, to get the error message. Okay. In this case, we have a logic app that is going to receive the resource group, the run ID, subscription ID, and workflow name. Okay. With that, is going to call the REST API, the Logic App REST API, that is subscription, resource group, and we have to set up that in a dynamic way, because we need to get the error of a specific run ID. And this Logic App is created in a generic way that we can reuse in all our Logic Apps, because we don't want to implement for each Logic App that we have all these actions to get the error message only. Okay. And you see that there is going to be several actions. So we have some initialization variables here. Then we do a call to the REST API, Logic App REST API. We are going to filter the array from the failures, and then we are going to see which type of errors that sometimes can happen, different types of errors, and the error message is in different places inside the history. And based on the type of error, we are going to get that information, set the body of the error body, and then return back the error message. Okay. So if you see now, we have the same logic app now, but now instead of having the error handling with the default capabilities on the catch, we are invoking that generic logic app. Okay. So now if I do the same and try the same request, okay, and send it, now the result is no longer a generic error, but error converting an XML to JSON. Okay. So if you go here to see it better in a good resolution, this was the last run, and then I got the same error, XML to JSON, bad request. It's error converting the XML JSON, and now on the response, this is what I got: error message, error converting XML to JSON. So in a dynamic way, I got the exact error message that I want to log in my system, because this is the message that gives me the details of the fail, not that the generic error saying that something failed. Okay. In this case, it is a logic app, and I'm using in here I'm using a logic app consumption, but logic app standard is going to be the same. Okay, so we actually can go for the logic app standard that I have here, and workflows. And I do have the same implementation here. Okay, I have the same logic, and at the end, I'm invoking a component to get the error message. Okay. Oh, come on, let's go fast. while this is opening, I'm going to show you just another way that you can also do this, but instead of using a logic app to get the error back, we can use an Azure function, okay? Just, I have here an Azure function that basically accepts subscription ID, resource group, run ID, and with that, what it's going to do is do a call to the REST API internally, okay? Of course, we need to set up the authorization to invoke this REST API and be allowed to query this, okay? And then we are going to filter that history by the failures. And then based on the error, we get the error message from one place or we get from a different place and return back the error message to the logic app with the exact same error. Okay, so if I do try this, and I have again here a third call that is going to be the same, but instead of calling to a logic app, a child logic app is going to call an Azure function, we get the exactly same error, okay? So error converting in XML to JSON, and again, it's going to be the same, okay? So let me see if, why, overview, developer design, okay? I don't know why this is slow, but, okay. So again, and this is Logic App standard. I have the HTTP request, the initialized variables, the call as a function with conversion that's going to give the error, and I do have, in this case, I use the function as a function to get the error message. And again, we get this error message and it works the same. The only difference between the consumption and the standard is that consumption, we need to have an input, the subscription ID, the resource group, the logic app name, and the run ID. And on the standard, we need an extra one. We need the subscription, the resource group, the logic app standard name, the workflow name, and the run ID. Okay, just to query the REST API from logic app standard that is different from the logic app consumption. Okay, part of that, we get the same logic and get back the same error into our logic apps. And by doing that, we create a generic kind of framework to get the errors and present the errors, and you can reuse it inside all of your workflows or logic app consumptions, okay? Now, a good idea also, instead of calling directly the logic app, is the Azure function or the logic app, you can expose that inside the API management and call the API management so to be a layer of in the middle. So if something change on the APIs on the workflow, you don't need to repoint each logic app. You just modify on the API management, and that's going to be more flexible. Okay. Now we know how to catch exception, control errors. We know how to get the error message. The last thing that we need is to know how to throw an exception. Okay. Again, there is no action, out of the box action to throw an exception. Okay. The only option that you have to throw an exception is, for example, create an action. Let's say a variable. Okay. Set a variable. Let's say that we are going to set up one of the variables and put, for example, in and put error. Maybe it's with a comma, sorry. So this conversion will fail and will raise an error, but this is kind of the way, and then you can play a little bit with the variables to set a proper error message to get this, okay? It's not the ideal, but yes, you can do this kind of stuff. Again, not ideal to have this because it has a lot of additional actions and you're just causing something to break, not really raising in a custom exception, okay? So there is no no actions out of the box to say throw exception like we can do it in C#, okay? Now, the way we can do that is, well, we have two options, or I like to use two options. Of course, you can use a logic app. For example, I have here a logic app that is, I call it common throw exceptions. Basically, I receive an error message, and what I'm going to do is return back a 500 with that error message back. Okay, so basically I'm forcing these to throw back an HTTP request with 500, and that is going to raise an exception on the other side, and with the same capabilities that we show earlier about getting the error message, I will get this exactly error message back. So I'm getting the throw exception, that message that I raise on my during my workflows logic. Okay, that's a way. Another way is also to create an Azure function, a dummy kind of Azure function that it says, okay, I receive the request body and I'm going to give back a bad result, kind of a 400 or a 500 with that request body. Again, I'm going to send text, raise back as an error, and then I catch that message back, and that's it. Simple as that. Okay. And that's an option, and this is the option that you let me see, kind of see here. That's calling an error message through exception. But what we can do also is to, for example, if you already have an API management, we can create an API there that do this for you. So I basically have this throw exception error here, and I have this policy here. Let me see if I can show it better, maybe later. So this is the, I'm getting the logic app name, I'm getting the logic app run ID, I get the body because I'm going to send a text with the error message. So I'm going to read that body and I'm going to return a response with the 500 plain text with that body back. So I'm actually doing the same as I did on the logic app or as I did in the Azure function. And with that, I have a throw exception, and I can get that exception on my cat scope. Okay, so if I try that now, and I'm just going to set this value instead of going to get the error by converting the XML just for throwing an exception. And if I call that back, call it again, you see that this is a custom exception from API. So if I go here on my process, for you to see it better, deployment tools, run history. You see that now it went to the right side of the condition, and it throws an exception that this is a custom exception from API management. and I got this exception on my catch, and I return it back to my postman. I return it here and say, this is a custom exception from API management. So with these kind of strategies, we can control all the errors. We can get the error message from our logic apps, workflows, no matter if it's standard or consumption. And we can throw exceptions very easily in a way that is going to be more flexible in our design of our workflows and to reduce the complexities of our workflows, just to kind of stop it in a place or in a validation that we want, instead of having complex nested if conditions. Okay. With that, that was all that I was intent to show you. I hope you like these small demos and how we drill down these error handling inside logic apps. And again, it was a pleasure for the invite me once again to be here on the Logic App Community Day. Thank you. And if you need anything, any doubt, just please contact me. Okay. Thank you.